I'm delighted to be joined by Ed Wilkinson from GScan. Ed, tell me about what your team does.
So the team in a broad sense, with bearing in mind we have teams in the UK and in Estonia, which is where we were founded. UK is largely sort of business development, solution design, customer engagement, market development, although we have a new civil engineer joining us from a technical standpoint in October, who will provide the sort of technical component, the on-bridge sort of knowledge, engagement with the client's technical team to ensure that we are understanding what actually the objective is. So that sort of real sort of focused, lens. What are we looking at? What's the objective on a specific asset bridge, largely in the UK currently. And then in Estonia, we have both software, AI, ML development teams. We have the hardware development team, and then we have the sort of back-end bridge engineers who've been supporting us up until the new civil engineer joins us in the UK. So that breaks down. We took on the AI ML piece in November of 2024, recognizing that that plays a really important part in how we analyze the data that is generated by the muon tomography through our hodoscopes, our scanners that are deployed on the bridges. And so the software engineers are always enhancing the software to enable us to provide a quicker analysis of the raw data coming off the hodoscopes. And then we have innovation around our hardware. So we have two scanners. We have an XL version, which is about 2.5 meters by 1.4 meters. And then the standard original scanner is about 1.2 meters by 1 meter. They contain very sophisticated electronics, scintillating fibers that captures the muon tomography or the muon flux as it passes through the scanners, through the asset of interest, to provide us with the sort of the energy change that gives us that visualization. So it's all about innovation. It's all about development. It's all about ensuring that the software and the hardware meets the objective that we are trying to understand as the beachhead in the UK as to what problems are we trying to solve.
Fantastic. And so that sounds, a real full stack from hardware, software, and engineering working together. How does that translate into actual decisions about asset management maintenance?
Yeah, sure. Look, I think, ultimately the technology was built because we saw a problem, and we saw a problem that needed solving. So we created some technology to solve that problem, which I think is from an infrastructure perspective, is a really important path to market. Not just building tech and finding a problem. It's the other way around. So the data that is being generated, are we making maintenance decisions? No. Are we producing comprehensive, detailed, three-dimensional illustrations of the internal critical elements of an asset? Yes. Are we providing detailed reports around what the data actually means, both visually but also in a content perspective? Those two sort of pillars of data are the information that enables our customers, the owner operators, the AECs, to provide either maintenance decisions, or from an AEC perspective, to provide the right level of advice to their customers about making more considered decisions around maintenance programs, as built record, when there's an absence of such information, at a time where budgets are super constrained. So being more targeted, more strategic about their asset management spend.
And you said you start with the problem. So what is the problem that your customers have?
As you will understand, you have destructive testing and you have non-destructive testing. The existing non-destructive technologies do not go deep enough. So really, the non-destructive testing current technologies provide a degree of visibility as to where there might be need for maintenance or invasive intrusion into an asset, and then you have to go into it physically. What we provide is that sort of invasive visualization without having to to dig a hole in the bridge. So the muon tomography provides that sort of, dare I say, and I'm going to get into trouble for saying this, that sort of safe X-ray, bearing in mind the muon flux is safe, harmless solar radiation. But we provide that real level of internal critical element visibility comprehensively to the customer, overarching and working with the other non-destructive, so the GPRs, the sonic, sound, etc. Those are our collaborative partners because they start the journey and they probably identify where there may be a challenge, and we can dive much deeper into that through that internal visualization of grouting issues, corrosion, breaks in strands, trouble with the anchorage points on an asset of interest.
And so, I mean, I just think about the data and the decision making that the client or their advisors are having to do. We're going to kind of start talking about AI and how AI assists with that decision making. If you could kind of, I think we're recognizing that there's a challenge with the data. You mentioned as-built records, like the current state and the condition. My view is that decision making is driven from data
Yes.
in the initial, or you can't make good decisions without data. And so,
Correct.
yeah, I just wonder what your thoughts are with that.
So look, I think there's a recognition. Firstly, there's a considerable volume of aging infrastructure that needs to be assessed. Currently, you couldn't begin to even scratch the surface of that with the existing non-destructive testing capabilities. The AI component to GScan enables us to take an asset, a concrete post-tension bridge, let's use that as an example. We look into the asset and the AI enhances the data. It joins the dots up of where the gaps might be. And if you take as-built records, there's been a real problem with the upload of analog material into a digital format. There's been an absence of records, lost records, poorly uploaded records that has meant a lot of the early stage baseline isn't even there for these assets. So there's a real need to actually get the baseline, and we're working on a project at the moment where there is, in some instances, no baseline on assets. So we are able actually also not only to do non-destructive testing and integrity assessments, but we're also able to provide that baseline. Because what the AI does for us, not only does it enhance the data, but so in a post-tension bridge where there's a lot of concrete, we're able to strip out the concrete and just see the critical elements, the rebar, the ducting, the anchorage points, enabling a customer to not be blinded by the sort of the unimportant areas, where there might be cracking, which of course is important, but what they're really interested in is that skeleton of the asset, which we're able to provide a comprehensive view of.
Right, thank you so much. And what does that look like at scale? How do you see GScan achieving that for, I mean, infrastructure, tens of thousands of assets, even just in one country or one asset owner? What does that transition look like?
So look, there's a few answers to that question. But I think, from our side, it's looking over the horizon to the future around innovation. Our hodoscopes are quite heavy, and their field of vision is ultimately the size of the hodoscope, so 1 meter 2 by, so looking at ways of embedding sensors, for example, into new build bridges, with a view that in time we'll be able to run a smaller scanner over the asset, and it will just capture the data that is being continuously gathered by the sensors in the bridge. But currently, what we're looking at is, because we're not cheap, let's be very clear, right? A single scan point is £18,000. That gets you get a full report, you get all of the scanning, etc. But if you look at it from a cost perspective on a single asset, you probably might think that's quite expensive when I could just run GPR over it for a couple of grand. But if you look at it from a portfolio perspective and you take a number of bridges and you say, okay, there's 10 bridges, and let's say we need to do 4 scan points on those bridges. So that's, call it 100 grand for the sake of argument. So that's £1 million on 10 bridges. But the level and the robust nature of the data we generate will enable considerable, really considered decisions around where we spend our money. And it is highly likely that we will prevent unnecessary activity, certainly unnecessary invasive activity. So it's all about saving. So it's really about value over cost if you apply that portfolio approach to that group of assets and say, okay, I've spent £1 million, I've saved myself £5 million, and I've also saved smashing open a bridge to which then obviously lets in moisture and lets in all sorts of evils that causes additional damage. You think of the traffic management component, you think of the disruption to the local economy. There's all sorts of interesting sort of ripples that flow out of poor decision making in asset maintenance. But what we bring is that enhanced, greater levels of detail, meaning that ultimately the asset owner community are going to save money. The greenest asset is the asset that's already built. So if we can really start to help preventing asset owners from making poor decisions around decommissioning, unnecessary maintenance, then we've achieved our objective. So the now is about portfolio, data-driven asset management. The future is about innovation of our hardware and our product.
Perfect, thank you. It being about the portfolio, not just the asset, really resonates with the work that we're doing at Mind Foundry. That we see a lot of interventions at an asset by asset thinking, but really when you're faced with a constrained budget and like the constraints of running a network, you have to think at the portfolio to get the benefits, not just at the individual asset. Ed, thank you so much. Is there anything else you'd like to share before we finish?
Look, I think the only piece I would share is almost a question to the industry. How do you become bolder in adopting technology that makes your lives easier? And what do we as the infrastructure technology providers need to do to enable that to be possible? And I think that comes to more communication and openness on the industry side, and also us being able to really articulate the value that we bring to the sector, because we've got to collaborate more. I mean, it's very simple. Everyone's got to talk more, and we've got to collaborate as a team to drive the value into the infrastructure sector. Because if we stand in silos, we're never going to achieve the objective. It's very simple.
Right. Well, thank you so much for your time today, Ed, and look forward to speaking to you soon.